Have you ever wondered how some of the worst engines in history made it past quality control? We're about to show you 10 legendary failures that had mechanics running for cover. From oil-guzzling V8s to explosive turbos, these are the absolute worst engines that somehow made it into production lines. Now, if you haven't subscribed to our channel, you can pause the video and do so now. That way you won't miss out on our upcoming videos on everything you need to know about cars and their engines. Now, let's look at 10 notorious engines that made mechanics rich, starting with our number 10 pick, the Cadillac V864. In 1981, engineers at Cadillac sought to improve fuel efficiency for its range of heavy, luxurious vehicles. Called the V864 or displacement on demand, the engine switched cylinder configurations, deactivating two cylinders at once when power requirements lessened. The concept was spot on, but the technology at hand to execute it was lacking. With a volume of 368 cubic inches, solenoids cut off the oil pressure to uniquely engineered hydraulic lifters, leading to the lifters collapse and successfully stopping the cam lobe from opening the corresponding valve. The major issue with the V864 was a noticeable lag when cylinders were turned off, often referred to as a drivability concern. The same engine reappeared in 1982, lacking the cylinder deactivation feature, and thus was largely regarded as a solid engine. Number 9. The Mopar 2.2-liter i4. Introduced alongside the successful K-Car series, the Mopar 2.2 quickly earned the reputation of a rod knocker. Faced with numerous breakdowns, Mother Mopar made a surprising move and equipped it with a turbo. This might have been acceptable had it stayed limited to the specialized Shelby GLHS and Dodge Daytona, which were quite sleek front-wheel drive vehicles back then. But Mopar opted to extend it throughout the entire lineup, from the full-size Chryslers to the incredibly popular minivans. In total, millions of turbo 2.2 engines were manufactured, and although many remained functional, a significant number created difficulties for both owners and service technicians. Remarkably, when restructured for optimal performance, the 2.2 has demonstrated to be a robust base. Nonetheless, in their original condition, their poor reputation persisted. Number 8. The Oldmobile 350 Diesel. The GM corporate partners expressed sorrow regarding its diesel failure of the early 80s. Typically regarded as an Oldmobile engine, this modified gasoline motor was utilized across the GM lineup, even appearing in high-end Cadillacs, resulting in unfortunate outcomes. Failures were frequent, typically involving internal engine parts. During that period, mechanics and service writers called warranty repair orders AFA, meaning automatic factory acceptance, and each franchise had large volumes of repair orders associated with the 350 cubic inch diesel. Number 7. The Chevy 2.2-liter i4. Now, recently substituted by the completely revamped Ecotec 2.2, this pre-Ecotec inline engine was a failure. Weak in performance, inconsistent, and prone to head gasket failures, the deficient four-cylinder engine was available in numerous GM front-wheel drive models such as the Beretta and Cavalier and the well-liked Chevy S10 GMC S15 truck series. At that time, press reviews advised against supporting these engines with automatic transmissions, particularly in pickups. With feeble strength and inconsistent reliability, what could be more undesirable? A number of steel freeze plugs were also recognized to rust, creating a chaotic time bomb that might erupt at nearly any mileage beyond 50,000. It's not surprising that GM incorporated no engineering or design elements from this engine when creating the Ecotec. We believe GM ought to provide Ecotec enhancements to all individuals with these inferior engines. However, the designs differ greatly, making swaps quite challenging. That's quite unfortunate. Number 6. The first Ford V8. Henry Ford's initial V8 was launched in March of 1932. Boasting a displacement of 221 cubic inches and an impressive 65 horsepower, it guaranteed to accelerate America more swiftly. Nonetheless, its technology revealed multiple design imperfections. Metallurgy was just starting out, and as such, piston rings were not yet crafted from adequately hardened steel, leading this engine to consume oil. The cooling system faced design issues resulting in the rear cylinders consistently operating at higher temperatures than the others. The intake manifold caused an incorrect air-fuel mixture from the one-barrel carburetor. One bank operated with excessive funds, the other with insufficient funds. This engine provided merely 10 miles per gallon of fuel in addition to a dismal 100 miles per quart of oil. Insufficient water jacketing, a faulty ignition system, and leaking water pumps all led to issues. Number 5. The Ford 2.8-liter V6. Available in the smaller Mustang and Capri along with Ranger trucks, the Ford 2.8 lingers as a shaky recollection. The 2.8 has a dual reputation owing to its loud solid lifter valve train and fractured cylinder heads, and it should be praised solely for providing World products the chance to benefit from its flaws. When World decided to create entirely new Ford V6 heads as substitutes for the original components, we doubt they could have anticipated it would turn into their best-selling item. In a lineup featuring some of the finest aftermarket performance cylinder heads ever made, the humble Ford 2.8 V6 replacement outperformed all others in sales. That should indicate how poor the factory design actually was. Number 4. The Vega 140 overhead cam. This model was manufactured between 1970 and 1977. During that period, John DeLorean was part of Chevy's executive team and allegedly remarked that the design of this engine was similar to a pre-war tractor engine. Although some people may not know, this small four-cylinder had silicone-impregnated aluminum cylinders instead of that cast-iron sleeves typical of most aluminum blocks. At the start of production, Chevy recalled approximately 132,000 vehicles to address the potential risk of a carburetor fire. Additional design features were evident as the blocks experienced distortion from overheating and the cylinders were susceptible to wear, leading to an unusually elevated oil consumption. Number 3. The Lincoln V12. Starting in 1940, the Lincoln V12 was created following directives from Henry Ford. Its fundamental design features were derived from Ford's current V8, although the V12 was developed with a 75-degree angle. Unexpectedly, it generated around 110 to 120 horsepower, even though it had a large number of cylinders. Similar to various early power plants, issues with overheating arose, leading to warped cylinders and high oil consumption. Similarly, initial models experienced inadequate crankcase ventilation, leading to unwanted sludge accumulation. Subsequently, engineering modifications provided a significantly enhanced crankcase ventilation system and included hydraulic lifters for quieter and more dependable functioning. Number 2. The Cadillac HT4100. Cadillac does it once more. This time it was an effort to create a lighter 4.1-liter engine known as the HT4100. This engineering wonder included an aluminum block and, for reasons unclear, cast iron cylinder heads. Displacing a mere 249 cubic inches, it generated a scant 135 horsepower at 4,400 RPM. A significant number of its problems were linked to defective head gaskets, which permitted coolant to enter the crankcase. Consequently, this sequence of occurrences led to GM providing a large quantity of crankshafts, camshafts, and associated components through the AFA program. Even when they sprinted, the HT4100 was severely lacking in power. Consequently, Cadillac experienced a decline in sales and reputation, challenges that required many years to address. And number 1, the early carbureted Buick V6 Turbo. Aiming to take advantage of the industry's shift towards smaller engines and vehicles while consumers craved power, Buick staked its future on the 231 cubic inch V6 Turbo. 3 years after the introduction of unleaded fuel, the sole option at the pumps was a water-like 87 octane. You don't require a PhD in engineering to understand that a draw-through carburetor paired with a turbo lacking an intercooler was not the smartest approach for the fuel and engine management technology at the time. The compact Buick was also available in turbo variants with 2 and 4 barrels. The anticipated solution was a black box, which was a gradual analog timing/boost regulator positioned atop the radiator fan shroud. Troubled by intense explosions, scorched pistons, and enough turbo delay to form a 5 o'clock shadow, this Buick failed to garner public support for the new engine technology through any effective PR efforts. Moreover, a subpar intake manifold design not only contributed to the detonation but also led to idle instability and tarnished Buick's reputation for seamless operation. Unfortunately, the engine had a balanced crankshaft that removed the vibrations of the previous V6. In 1984, a suitable ignition and engine control system was installed alongside port fuel injection. The year 1986 introduced additional modifications to the induction management system with the relocation of the turbo and the addition of an intercooler. It is difficult to imagine that the now famous Buick Grand National V6 Turbo started from such modest origins. And there you have it, 10 engines that probably should have stayed on the drawing board. Think we missed any automotive disasters? Drop them in the comments section below. We've got plenty more automotive history, mechanical breakdowns, and industry secrets coming your way, so don't forget to hit that subscribe button, and we'll see you in the next video.